Hello. Hi everyone, this is Siddharth Rathore. Now I welcome you to these particular classes on microeconomics. Now this particular section that we are taking is from Intermediate Microeconomics 1, which is a semester 4 course of economics honors under NEP. Now, the topic that we are going to take is general equilibrium and basically exchange economy. Now, this particular part of the course is extremely important, not just from the perspective of your final examinations, which are forthcoming, but also from the point of view of, say, entrances like the UPSC Indian Economic Services or the even the IAS or the CUET PG exam or RBI Grade B. So, the relevance of this particular topic is extremely important. Now, to cover this particular topic, we have Dr. Komal with us. She's done a master's from Delhi School of Economics and a PhD from ISI Delhi. And she's also been teaching at OP Jindal University. Now she'll be taking up this particular topic for explanation, and whatever doubts that you are having, you can put them on in the comment section of the YouTube video. Thank you very much. So I hand over the mic to Dr. Komal.
Thank you, Siddharth. Hello everyone, and welcome to this video. I'm Komal, as Siddharth already introduced, and I have been given to understand that this particular topic is a pain point for economics students, economics honors students, and I completely empathize with you. It was a pain point for us also, and the major reason is that this does require a sort of understanding or sort of perspective that is new to us, and if that is not understood correctly, we kind of tend to be lost on all these things. So this is the basic structure of this lecture, that these are the points that we will be covering. So we'll start with an introduction of what we are trying to do and why we are trying to do this. Then we'll go on to discuss the structure of the economic model that we will study, and this is where we'll also introduce the Edgeworth box that you must have learnt about. Then we will talk about the concept of welfare in this economic model of ours, and we'll use the concept of Pareto efficiency or Pareto optimality, and we also discuss what is a feasible allocation in this context. Then we will move on to what is called a contract curve. I'll explain everything. Finally, we'll see how we reach a competitive equilibrium, and in this after this entire discussion, we will finally discuss what are the fundamental theorems of welfare economics. So these are also called the welfare theorems, first welfare theorem and second welfare theorem, and we'll see what these theorems are all about and what they are essentially saying. All right. So first of all, let's understand what we are doing. So far, what you have done what is called a partial equilibrium analysis. Partial equilibrium. So when we say partial equilibrium, essentially what we are saying is that, think about it. If you were learning about from the production side, you were thinking about one product, right? You were thinking about this particular product, this particular production function, this particular market. Monopoly hua to, then you thought ke is particular product mein is particular firm ka monopoly hai, right? Without caring about what was happening in the other parts of the economy, right? How were those things affecting this particular market, and how was this market affecting the other parts of the economy? So you chose to ignore them. You could have either assumed कि बाकी जगह everything else is constant, right? The ceteris paribus assumption that we have, or you just chose to ignore them. You said that, okay, we will not worry about what is happening there right now. We will focus on the particular thing that we care about right now. So if you're looking at consumers, then you're only looking at consumers and not worrying about the production side of the economy, right? This is called a partial equilibrium analysis, where you are abstracting away from movements in other parts of the economy and focusing only on a partial part of it. As opposed to what we will now learn is called the general equilibrium analysis. So when we say general, then it means that we are considering everything together, all moving parts together. So when we are looking at, we are also looking at the production side, we are also looking at the distribution side, we are also looking at the input market, we are also looking at the output market, right? We are looking at the trade, we are looking at the internal economy, everything. General equilibrium, because we know that whatever happens in one part of the economy will affect and will be affected by things that are happening elsewhere, right? So then, instead of abstracting away from whatever is happening Elsewhere, we will now study all the moving parts together, right? And as you can imagine, this is definitely a humongous task, right? So if you have to consider everything at once, then you will at best be lost, right? So then way to do it is to start small, and this is what we will do. So we will start small. What we will do is we will only start with what is called an exchange economy. So what is an exchange economy? This economy has no production, or rather you can think of that, how does the economy work? So there are inputs, they are employed in the production process, there's production, you get output, and then the output is finally distributed among people, allocated among people based on whatever their budget is, whatever their utility is, right? We will start, अभी हम ये initial process को ignore करेंगे, हम सिर्फ अभी उस exchange और distribution या allocation वाले part पे focus करेंगे, right? So this is the economy that we will focus, of course, and in later lectures and in later parts of the analysis, we will add these other parts. Of course, we are not going to ignore them, but within the exchange economy, we will focus on everything. We'll focus on all the markets that exist, right? So this is what is an exchange economy. This economy essentially does not have production. You can think of this economy where production has already taken place. A certain set of goods exists, and the only problem that we are considered with right now is how to allocate or how to distribute these existing set of goods. Okay, so let's discuss the basic structure of this economy. This economy will have two consumers. So traditionally what happens is this economy was considered that, there's this book called Robinson Crusoe, and this book is about this person who is stranded on an island because this person went on some sort of sea adventure and there was an accident, and this person got stranded on this island where he was alone for a lot of time, and after some time another person named Friday joined this person, and Robinson Crusoe and Friday, these two people were living alone on that island. So to abstract away from everything else, to look at this isolated island as an economy complete in itself, this is the story that this is the book that we draw inspiration from. But we are Indians, तो हमको बहुत ज़्यादा Robinson Crusoe और Friday से relate हम नहीं कर पाते हैं. This is something that was true for me. So what we'll do is we'll give them some desi names, right? So we'll work with Rahul and we'll work with Fiza. The reason I've chosen these names is because I wanted to keep the initials same. So R is Robinson Crusoe and R is Rahul, and Friday is also for Fiza. Okay. The reason is that when you go back to the book that you will refer to, you will find the same initials there, and then it will be easier for you to relate. Okay. So we have two people on this island, Rahul and Fiza, and this economy has only two goods. Okay. वो दो गुड कोई भी हो सकते हैं. इसमें what they consider is bread and rum. You can also think of any other goods, right? This is something that is essential. This is something, this is something that is essential to eat. This is something that is, you can think of entertainment or leisure kind of product. But essentially at the end we'll call them X and Y. So any two products. Anything less than this, so if you have only one consumer, then there's no need for any exchange, then the analysis becomes moot. Similarly, if you have two consumers but you have only one good, then also there's no exchange. कोई exchange की बात नहीं है. Exchange तब होता है जब there is a trade, that you give me some of X and I compensate you with some of Y, right? So this is a trade, this is the barter, and this is the kind of thing that we will deal with, right? So 2 points about this economy. First of all, as I said, there is no production in this economy. Goods have already been produced, or they have been procured, or they have been found in the nature, they have been inherited somehow. वो हमारा concern नहीं है. हम वहाँ से शुरू करेंगे जहाँ पे हमारे पास जहाँ पे हमारे पास एक endowment आ चुका है. There is also no money in this economy. So there is no money, there is no currency that is going on. This is, you can think of the economy where all kinds of exchanges take place in terms of goods themselves. So that's why it's a barter or a trade economy. So any kind of, if you want something that the other has, the way you can pay for it is with something that you have, and you don't have money, you have bread and rum. ठीक है. So what we will do is we will denote we will use capital X to denote the total endowment of good X, right? So suppose X is the total endowment of bread, capital Y is the total endowment or total available amount of Y on the island. ठीक है. अब ये total है तो ये किसी ना किसी के पास तो होगा, right? तो what will be true is that suppose before that let's use some notations. Suppose you have to see how to denote a bundle for Rahul. Suppose Rahul के पास कुछ initial endowment होगा या कोई भी endowment होगा, है ना. मान लो कि 5 units of bread हैं, 10 units of rum है. So what we will do is we will use X is the number of units of good X and R will be the subscript which we will use to denote Rahul. ठीक है. So X units of X, Y units of Y for Rahul. Similarly, XF and YF is the any arbitrary allocation, any arbitrary bundle for Rahul and Fiza respectively. Okay. And since we know that there is an allocation, there is an availability, both of them will start with an initial allocation. Okay, so both of them will start with an initial allocation where we will use this not symbol. Okay, this ये जो है ना not essentially denoting T0, मतलब जहां से हम शुरू करते हैं तो उसको डिनोट करने के लिए हम लोग ये नॉट सिंपल यूज करेंगे. सो एक्स आर नॉट, वाई आर नॉट विल बी द इनिशियल बंडल और इनिशियल एंडाउमेंट विद विच राहुल स्टार्ट्स. सिमिलरली YF, XF naught and YF naught will be the initial bundle with which Fiza starts. And two identities which will be very useful is that अगर तो पूरे आइलैंड में टोटल X है तो ये X या तो राहुल के पास होगा या तो फिजा के पास होगा. ठीक है. अगर किसी के भी पास नहीं है तो वो तो then that doesn't become part of analysis. Okay, so we assume that there is no hidden resource. Also we assume that if the resource is hidden then it's something that we are not considering and there is no wastage. Okay, so total initial endowments of X's of Rahul and Fiza should sum up to the total endowment of X, and similarly total initial endowments of Y for Rahul and Fiza should sum up to total Y. All right. So this is the basic structure of the economy: two consumers, two products, initial endowments, no money, only exchange. Okay, and finally we will discuss about their utility. ठीक है. So अब ये हमारे पास बंडल है, उस बंडल से यूटिलिटी कितना मिलता है वो as usual we will denote by how much I value the particular bundle will be denoted by how much utility I get. So this will be the notation that we will use. The utility of Rahul is given by U subscript R and utility of Fiza is given by U subscript F. So you should note the important thing is that the arguments of this function are only the only the bundle that Rahul has, right? So what it means that Rahul's utility is only determined by how much bread and rum he has and has nothing to do with how much bread or rum Fiza has. So this model has no jealousy, this model has no altruism. ठीक है. मुझे इससे फर्क नहीं पड़ता कि तुम्हारे पास क्या है, जितना मेरे पास है, my utility will be determined by that. Right? So Rahul's utility is given by UR, which is a function of Rahul's bundle, and Fiza's utility is a function of Fiza's bundle only. The next step that we will do, given our utility, given our initial bundle, right, and given the total bundle of goods, total amount of goods that is available on the island or on this economy, we will represent this using a graph. And this graph is something that you may be familiar with. It's called the Edgeworth box. So this was developed by so this was first suggested by an economist whose name was Edgeworth, right? And this is how the box looks. So let me just draw the box on a new page. What we have is Edgeworth box. So this box looks something like this. It's a box, of course. All right. The unique thing about this box is that it has two origins. Okay. So one origin is for consumer number 1, which is Rahul. The other origin is for consumer number 2, which is Fiza. Okay, so you can think of, so let's just focus on one. This is your x-axis, right? So this x-axis measures the amount of good x. Okay, so this is the size, the total length of this, the total length of this axis gives the total amount of x. Okay, and this y-axis, let's just look at it here. This is the total amount of y that is available in the economy. All right, this is 0, which means that at this point x is also 0, y is also 0. Okay, now what we'll do is try to imagine the same thing, but imagine a mirror that is placed here, and therefore you get an exact mirror opposite thing over there. Okay, so this axis also measures this total, is also the total value of x that is available. So you have this, it's the same as this, and this over here is also the total value of y that is available. Again, it's the same. All right, the only thing is that this is also 0, this is also 0. So for one, you should think of it as going from 0 and the value increases this side, and if this is 0, then the value increases in this direction, value of y increases in this direction, value of x increases in this direction. If you're starting from here, and this is the origin for Rahul, and if you're starting from here, which is the origin for Fiza, then the value of x increases in this direction. All right, value of y increases in this direction. Okay, from top to bottom. Okay, so then in this case, for example, take a point like this. Let's call this point W. This W is essentially, suppose this is the initial bundle, any bundle, the most attractive or the novel point about Edgeworth box, the most useful point is that you can denote the bundles of both these individuals, right, by a single point. How? This bundle, if suppose we were only on this xy plane, forget this other this inverted xy plane over there, just focus on this xy plane over here. If we are at this point, that means that that Rahul's bundle is what? This is the amount of x that Rahul has, right? So this is the length of xr. If this is the initial bundle, then this is xr naught, correct? And this is the amount of good y that Rahul has. So this is yr naught. So this bundle illustrates, or this bundle marks the point where marks basically Rahul's initial bundle, Rahul's initial endowment of goods x and y. So this amount of x and this amount of y. Now again, try to do a little thought exercise and try to imagine it from Fiza's point of view. If this is also the point or the bundle for Fiza, right, then we know that this is the x-axis for Fiza going in this increasing direction. So this is the initial amount of x, good x, that Fiza has, and this is the initial amount of good y that Fiza has. And why is this possible is because we know that this length, right, plus this length, the initial bundle or the initial amount of good x that Rahul has, plus the initial amount of good x that Fiza has, they sum up to the total amount of good x that is available. That is something that we have already established over here, right? Because these are the only two people in the economy, the total that they have is obviously equal to the total that is available. And using this very thing, the Edgeworth box essentially is able to map both these bundles by a single point on the Edgeworth box. All right. So I hope that the reading of Edgeworth box is clear. Okay. अब क्या करेंगे? अब we also want to represent the utility function, the indifference curves of both these individuals in the same Edgeworth box. Okay, again, let's start with only Rahul, and whatever we get here, we can do a mirror image sort of thing on the other side. So if this is a bundle, we know that an indifference curve basically is, if you have, if this is your x and y axis, indifference curves look like this, right? So this is the direction of increasing utility, and an indifference curve is the locus of all the points on which the utility of the particular agent remains the same. So different bundles, so if this is one combination of x and y, this gives individual some utility. This bundle where you give up some of the y and you gain some of the x, right? This bundle also keeps the person on the same utility curve. So it depends on the marginal rate of substitution between x and y. These are concepts from your first year, right? So the slope of an indifference curve is the marginal rate of substitution between x and y, and that is again the ratio of the marginal utility of x upon the marginal utility of y. So this is a concept that we will come to when we are solving for this model, right? So marginal rate of substitution between x and y is the ratio of marginal utility of x upon marginal utility of y. This is a concept that is used directly from the concept of indifference curves that you have studied in your first year. Okay, so what happens is, as you move along the indifference curve, you are giving up quantities of y and in return gaining quantities of x, so that you remain on the same indifference curve, right? And if you suppose there is a higher quantity of x, suppose take a point something like this, right? So at a point like this, what you have is a higher quantity of x, but maybe the same quantity of y. So since we know that x and y are goods, right? They are goods. That means more quantity means more utility, even though at a diminishing rate. But higher quantity gives higher utility, right? These are not bads; these are goods. So then, if you have higher quantity of x and the same, or maybe the same quantity of y, then you are bound to land on a higher indifference curve. That's why this is the way indifference curves. This is the way in which utility keeps on increasing. This is the direction in which utility increases as we go from one indifference curve to the other. All right. So now what we have is, this is the bundle. This bundle must give Rahul some utility, right? And again, taking this xy axis, there must be utility indifference curves passing through this. ऐसा करके there will be indifference curves for Rahul. Okay? So what we'll do is, let's sketch those indifference curves for Rahul. It has to pass through this point, right? And all the other points on which the utility of Rahul remains the same. So this is, let's call this the indifference curve of Rahul. Okay. This indifference curve will give Rahul the utility as given by this function. U r x r 0, y r 0. According to this function, whatever is the utility, this indifference curve will be marking that utility. Now, again, it's time to put the mirror and flip the exercise. For FISA, what you will have is, again, this is the bundle, but you have to look at it from a point of view that you put a mirror at this angle. So ये जो utility curves ऐसे upward sloping है और ऊपर को जा रहे हैं, right? Now what we will have is something like this. Let me use another color for this. So, okay, this will look something like this. This pink one will be the IC for FISA, right? And it will be exactly the same because this is the origin. You can now see that the utility of FISA is increasing in this direction, right? It will be something like this. The utility curves will be like this for FISA, and for Rahul, they will be what we have usual, right? So for Rahul, this will be the direction of increment of utility, and the curves will look something like this. All right. So this is the entire concept of Edgeworth box, where you can denote the bundles. If the bundles Of course, there can be bundles where they do not sum up to the entire X, right? We will talk about such bundles. These bundles are what we'll call non-feasible bundles. But right now, let's use the identity where the initial endowments, of course, add up to the total. Of course, initially तो ऐसा होगा ही कि जितना भी है, that will be distributed among the two. There will be no wastage, or we assume that there's no wastage. Okay, so this single point can mark 4 quantities. It marks the amount of good X with Rahul, good Y with Rahul, good X with Fiza, and good Y with Fiza. So this single point is able to mark 4 quantities, and because of this twin origin sort of diagram, we are also able to plot the indifference curves of 2 different individuals. Okay, all right. So now what we will do, let me remove these other indifference curves. So let's let that stay there. And what we will talk about is the concept of, so let's move on to the third topic. Let this be here. If needed, we'll redraw this. Okay, we'll redraw this, and we will focus on this particular point and how things move from there. Right. So now, once we have the Edgeworth box with us, and once we have the structure of the economy with us, to consumer to goods economy, no money, only barter, and an initial fixed quantity of X and Y. Now let's talk about the concept of welfare, or how to measure welfare in this sort of economy. So far, how have we been measuring welfare? So this is where we will cover Pareto optimality. So far, when we were talking about, suppose when we looked at the consumer welfare plus producer welfare, right? जो हमारा ये supply demand curve होता था, उसमें हम कहते थे कि whatever is the price, there is some welfare that goes to the consumers, and then there is some welfare that goes to the producers. And the usual way in which we measured this welfare was in terms of currency. So this was the price was in term of some currency, and then this was the difference in the willingness to pay, right? The price ends where the willingness to pay of the marginal consumer is equal to the price, right? So then this difference is the difference in the willingness to pay and the price. So in money terms, you get what is the welfare, or what is the surplus, right? What is the surplus that is generated by this market mechanism. So there is a price, there is some willingness to pay, or the price at which the producer is willing to sell. So then this difference gives the surplus of the producer. So that's what we had, that we could measure welfare, we could measure surplus in terms of some currency, whatever currency you choose, right? In a sense, it's like the size of the economic pie that is generated. This pie is generated because there is some economic activity. There is production, there is exchange, there is trade. All these activities generate a surplus in the economy, and the way we measured welfare was we summed up the measure of this surplus, which was in some currency term. We summed that up, and that gave us a measure of welfare. We summed up the surpluses of the two sides of the market. Suppose we summed up the surplus of consumer with the surplus of the producer. Since both were measured in monetary terms, right, in the same currency, we could add them up. उनका scale एक था, उनका unit of measurement same था, so we could add them up. Now the problem with this, what we face is that पहली बात तो यहाँ पे पैसे नहीं है, there's no money in this economy, right? And secondly, the issue is that you cannot just add utilities, right? Utilities are, first of all, this is more of a more of an ordinal concept, utility. Secondly, you may have the same bundle that gives different utility to different individuals. So that means that you cannot add utilities of two individuals together, because it's then adding apples and oranges. They're not comparable, right? So adding utilities across different individuals is a no-no. It doesn't make sense. And in the absence of money, we are in a bit of a soup then how to measure welfare in this sort of economy. And the solution to this is using the concept of Pareto optimality. So let's learn what that is. Okay. So for that, let us define a few concepts. The first thing that we will do is, let us define. So earlier what we had was, let's just recap what inefficient was, right? So any market was called inefficient when the size of the economic pie that there was, right, or the sum of the consumer and producer welfare, or whatever are the agents in the market, if the sum of their welfare could be increased. So if it was possible for the total welfare or for the size of the pie to get bigger, then the existing market was called inefficient, right? So like in a monopoly, right, or when you introduce taxes, unit taxes, per unit taxes in a system, then you get what is called the dead weight loss, right? So this loss is not going to any agent in the market. It's not going to the consumer, it's not going to the producer. This is basically a loss. ये एक loss है, and that's why this is considered as a wastage, right? And the market is considered inefficient. And an efficient market essentially is the market in which it's not possible to increase the size of the pie anymore. It's not possible to increase the sum of consumer welfare and producer welfare. Okay? So the most efficient market that we have seen, so this is the perfectly competitive market. Okay, so we will try to use this concept. We will try to use this concept of a possible improvement, whether a possible improvement is possible or not, to define the concept of welfare and efficiency in this system. Okay, so let's do that. So let us define, first of all, what is called a feasible allocation. So a few definitions that we will have. The first definition that we will have is what is called a feasible allocation. Okay, this is something that we have already done. A feasible allocation will be any allocation such that, so an allocation will be what? An allocation will be a pair of bundles, one with Rahul, one with Fiza, right? So any pair of allocations, XR, YR, this is Rahul's allocation, and XF, YF will denote Fiza's allocation. This is, Fiza's bundle. A pair of bundles will be called an allocation, right? This is how the goods have been allocated to the people in the economy. So this is an allocation. Now these numbers can be anything. This allocation will be called a feasible allocation if the total available X and the total available Y is exhausted in the economy. Right? So there is no wastage, there is no throwing around of things, there is no one hiding any particular quantity of any good. So a feasible allocation will be, this allocation is feasible if XR plus YR is equal to X and XR plus XF is equal to X and YR plus YF is equal to Y. Okay. When we use an Edgeworth box to denote things like this, so consider two examples. Suppose this is one case. Again, this is X and this is Y. This is Rahul and this is Fiza. Okay. Suppose there's an allocation like this. Okay. This is Rahul's allocation. So this is XR0 or XR and YR, and this is XF and YF. Okay. The problem with this is that see, this is the total amount of X now that Rahul has. Right? This is the total amount of X that Rahul has, XR, and this is the total amount of X that Fiza has, right? XF. And we know that this plus this actually exceeds the total available X. So simply this is not feasible. You cannot have more endowment than that, then there is actually available, right? So this just doesn't make sense. That's one kind of non-feasible allocation. The other kind of non-feasible allocation will look something like this. So this allocation, suppose again, this is your Edgeworth box, where this is the bundle for Rahul and this is the bundle for Fiza. In this case, what we have is that this is the amount of X that is with Rahul, and this is the amount of X that is with Fiza. The problem is that this and this is less than this, correct? XR plus XF do not sum to X, do not sum to the total. Now, while technically this is still feasible, that just means that there is some wastage. What we will do is we will not consider even this as feasible. Okay, and the reason will become clear once I come to the definition of Pareto optimality. But this is something that we will also not consider to be feasible. The only points which are feasible, the only allocations which are feasible in this economy will be the allocations which can be represented by a single point on the Edgeworth box. If you have a single point representing both the allocations or both the bundles of both Rahul and Fiza, that means that this point, suppose a point like this will essentially necessarily add up to the total allocation of X as well as to the total allocation of Y. So only those points which can be only those allocations which can be represented by a single point on the Edgeworth box will be considered as feasible allocations. All right. This is the first definition, which is feasible allocation. Now let us talk about the second definition. This we will call what is called Pareto domination. So what is the concept of Pareto domination? Suppose A and B are two feasible bundles, right? So you have two. Now from now on we will focus on bundles that are feasible, focus on bundles that exhaust the available resources of both X and Y. All right. So now suppose A and B are two feasible allocations. Then we say that A Pareto dominates B, right? A Pareto dominates B if both Rahul and Fiza, okay, like the bundle A as much as they like B, with at least one of them preferring A over B. Okay, so what this means is that let me write it. So what we are saying that there are two bundles. So for two feasible bundles, A and B, A Pareto dominates, I'm using this as short, Pareto dominates B if both Rahul and Fiza like or prefer, this is the same thing basically if their utility is higher, right? Like or prefer A as much as B, and at least one of them prefers it over B. So essentially, if suppose there are two bundles, two allocations A and B, right? If suppose FISA is indifferent between A and B, right? So she gets the same utility if she has the bundle under allocation A as she would be in under allocation B. But it's Rahul who is happier if he has the bundle which comes under allocation B. Sorry, we are doing it A dominates B, right? So FISA is indifferent between these two, but Rahul prefers A because Rahul has a better bundle which gives him higher utility when the allocation is at A rather than B. So then we say that A Pareto dominates B. At least one of them. It could just be the case that both of them prefer their bundles under allocation A as compared to B. But it is sufficient that only one of them prefers. So it's not required that both of them should be better off at A as compared to B. Even if one of them is better off at A as compared to B, and the other one is not worse off, other one is indifferent and one of them is better off, then we call this that this Pareto dominates B. Pareto dominates B. Okay? Right. The third definition that we will do is what is called a Pareto move. So we will use the same two bundles. So A and B are two feasible bundles, feasible allocations, and A Pareto dominates B, then a move from B to A is called a Pareto move. So when you are moving from a bundle that has, or when you are moving from an inferior to a more superior bundle in terms of Pareto optimality, in terms of Pareto domination, then it's called a Pareto move. Okay, and the final definition that we will have is what is called Pareto optimal. So Pareto optimal is so a bundle, any bundle, suppose a feasible allocation that you have. So a feasible allocation is called Pareto optimal if there is no Pareto, if there is no possible Pareto move from it. If no Pareto move possible from it. So that means that the bundle is such that if you move away from that bundle, right, first thing, so it won't be that both of them are better off, definitely, right? Even if one of them is better off, for sure, both of them will not be better off. So if any allocation A is Pareto optimal, then that means that if you move away from that allocation, if you try to go to a different set of bundles, a different allocation, definitely it cannot be the case that both Rahul and FISA will be better off, right? It can be the case that, say, Rahul is better off, but that would definitely mean that FISA is worse off. Not even the same. If it's the same, if FISA stays the same, then it's actually a Pareto move, right? So if there is no Pareto move possible, then we are essentially saying that any move from this allocation means that at least one of them is worse off. At least one of them is worse off. All right. It could be that you are moving to another bundle, but the two are indifferent among them, right? So then both of them are Pareto optimal. That's something that is possible, but it will not be the case that both of them are better off. If one is better off, the other will necessarily be worse off. If you have reached such a bundle in the set of allocations, then that bundle is called Pareto optimal. And the optimal, Pareto optimal or Pareto efficient, and we are using the same idea of efficiency that we have used so far, which means that the size of the pie cannot increase. So if you are increasing the size of the pie further from there, it is the increase is coming out of trimming the pocket of someone else, right? So if you are trying to increase the size of pie for Rahul, essentially फिजा की जेब से कुछ ना कुछ काटा जा रहा है, ठीक है? तो इस केस में both of them cannot be better off at some other point. The size of the pie cannot be increased without hurting someone, without making someone worse off. If there is such a point, that point is then called Pareto optimal, and this is the concept of efficiency that we will use in this exchange economy. All right. So now let us understand this point using the Edgeworth box that we have, right? So this is what we had. Let us again make that Edgeworth box where we had an initial allocation, all right, and the indifference curves. Okay. So within the same framework, that's why I want to tell you why this case is also not feasible. So why we say that it's not feasible? If you think of this as a feasible allocation, the point is that this allocation can never be Pareto optimal. The reason is that this allocation essentially, suppose this is an allocation and you're considering whether it or not it can be Pareto optimal. The fact is that there is some leftover X in this allocation, right? Even after things have been allocated to Rahul and Fiza, some of the bread remains, right? So in that case, this remainder bread can be given to either one of them or can be distributed among the two of them. And since bread is a good, it's not a bad, both of them will be better off, or at least one of them will be better off without making the other person worse off, right? So there is a Pareto move always possible from an allocation from a bundle like this. And that's why, since this bundle can never be Pareto optimal, we will discard these kinds of bundles. So from now on, we'll only focus on bundles that are feasible. That means that they can be represented by a single point on the Edgeworth box. All the existing resources of X and Y are definitely exhausted. Okay? And secondly, so this is the first point about a Pareto optimal bundle. The second point is that Pareto optimality has nothing to do with the concept of what we call fairness or what we call equity. Okay, so Pareto optimality Pareto optimal may or may not be fair, right? May or may not be fair. So unrelated. So we cannot make any definite statements about how it will be related to fairness or equity. Fairness or equity. So for to kind of understand this, think about the extreme example. Think about the case where Fiza has all the rum and all the bread, right? So Fiza has the entire amount of bread that is available and the entire amount of rum that is available, right? Total of X and Y. This point is Pareto optimal. And the reason is that if you wanted to give some of that bread and some of that rum to Rahul, if you wanted to, in an alternate allocation, suppose you wanted to allocate some of that bread to Rahul, some of that rum to Rahul, the important point is that Fiza even though like she started off very rich, right? She started off with all the things that have existed in her economy, but she will be worse off. And therefore, any movement away from this point will be Pareto inferior. It will not be Pareto optimal. It will. So this point where FISA has everything, that will Pareto dominate every other point that moves away from it. Every point that gives some of that rum and some of that bread to Rahul. So this is the point that will illustrate that even though a point is Pareto optimal, it is extremely unequal. It's extremely unequal, right? It's just essentially giving everything to FISA. Rahul has nothing. But this is not a concern, or this is not something that Pareto optimality controls. Okay? We will look at the efficiency property of Pareto optimality from the point of view of where we start. So this will become more clear from the example that we look at. So let's just look at Pareto optimal or Pareto dominated movements, Pareto moves in the Edgeworth box that we built. So right. This is the Edgeworth box that we had, right? So this was Rahul's origin, this was FISA's origin, and this is your total X, total Y. This is some bundle W that you started. So this is your XR naught, YR naught. Similarly, so let's call this W, XF naught, and this is your YF naught. Okay, so this is your initial allocation. Okay, and we know that there were two indifference curves that we had. Okay, so this was one indifference curve for Rahul, and this was the another indifference curve for FISA. Okay. Now, if this is the point where things have started, and we know that FISA's utility increases in this direction, Rahul's utility increases in this direction, right? So if we move to a bundle, right, which lies inside this lens sort of thing, right, both of them will be better off, because if suppose a bundle lies over here, another bundle, जैसे ये एक bundle है, if it lies here, Rahul's indifference curve will be what? Rahul's indifference curve will passing through this will be like this, and similarly FISA's indifference curve will also pass through this, and it will be something like this. That means that both of them have moved in the direction of increasing utility, and the utility that they have, so these are higher indifference curves for both of them, the utility that they have at this point necessarily is higher than the utility that they had in this point. So this point, let's call it P. This point Pareto dominates the initial endowment, and a move from W to P is what is called a Pareto move. All right. Now, as you can see, ये point भी बेहतर है, ये point भी बेहतर है, ये point भी बेहतर है, ये point भी, all the points inside this lens are actually better in terms of Pareto optimality, are actually improvements from the point W for at least one of them, right? If you land up at this point, if you land up at this point where their initial ICs were crossing, right? If you land at a point where the initial ICs were crossing, you will be at the same indifference curve for both of them. So then this and this point will give both of them the same utility. This point will not Pareto dominate W, but all the other points inside the lens as well as few points on the edge also. Okay, so as you can see, as you keep on moving, making movements, right? Suppose you first of all only make a movement for Rahul. So things will get better for Rahul as you go on this indifference curve, then this indifference curve, then this indifference curve, and finally this indifference curve. This is where you will stop. because if you try to make things better for Rahul beyond this indifference curve, you will land up at a point where Fiza is worse off than where she started. So if you go to a point even slightly over here, for example, then for Fiza, if this is the bundle that you're considering, then for Fiza, the indifference curve that she will be on will be lower than the indifference curve where she started. So you cannot go beyond this, right? So the only, so the point where you have to stop where these two become a tangent. So this IC of Rahul becomes a tangent to the initial IC of Fiza. So that is a point that is also Pareto dominant with respect to W. Okay? And now let's make movements for Fiza. Same way. So this is an improvement. This is an improvement. Finally, you have to stop. Sorry, you have to stop somewhere here. Okay, where you have made Fiza as better off as possible without making Rahul worse off than where he started. Okay, so in these two tangency points will be included, and all the points in the interior of the lens will be included, and these points will be the set of points that Pareto dominate W. So all points, let me shade it something like this. Which color? Okay, green. So all points in the interior as well as these 2 points. So these are points that Pareto dominate the initial endowment. All right. So before we move ahead, we have 2 points that we need to understand. First, if at a given point the 2 ICs cross, okay, before I get there, what you will realize is that even though all these are Pareto, all these Pareto dominate our initial endowment, essentially, whenever trade happens, whenever any sort of exchange of goods will happen, what is happening is, if you're at W and you move to a point like P, essentially what has happened is some of the at this point, right, Rahul has a lower allocation of X, lower allocation of the bread, and he has a higher allocation of rum than where he started. So essentially he has exchanged some of his bread with some rum with Fiza, right? So he gave he gave this much of his bread to Fiza, and she gave some of her rum to him, and therefore both of them now reached an allocation which was better for both of them. So he suppose values rum more than the bread that he has, or whatever he decides that a higher quantity of rum would give him more utility, right? So then he exchanges some of the bread that he had a lot. He exchanges some of that bread, gives it to Fiza, and in return Fiza gives some of the rum that she had on lying around extra that she gave to Rahul. Okay, so ye karne ke baad, whatever the final bundles that they had, they were better off, right? Now the thing is that even though all these are Pareto dominant, all these Pareto dominate this point W, the thing is that it's like this entire set of points will not actually be the final set of points, will not comprise of the final allocations. जिस तरीके से हमने यहाँ पे final allocation decide की, which was essentially where the 2 ICs become tangent. A final allocation will always be the point of tangency between the two, tangency of the 2 ICs. If it is not a tangent, then there will be scope for improvement. Okay? So then we have, from this point, we can see that, so we have 2 points. One, if ICs intersect at an allocation, it implies that it cannot be Pareto optimal. Just like the point W, you take any other point where the ICs are actually forming a lens, that means that there is scope for improvement, right? when there will be no, when the scope for improvement will actually be exhausted, where the ICs are no longer crossing, they are just touching, which means that they are tangent. Okay, so the second point, then it means that Pareto optimal allocation will mean that ICs are tangent. Unless ICs are tangent, you cannot have a Pareto optimal point. If it is a Pareto optimal point, your IC, it will be a tangency point between the ICs. And I hope this point is clear, because unless the ICs are tangent, suppose this is a point, any other point, it can either be the case that the ICs are like this over here, or it could be the case that the ICs are like this. If the ICs are like this, it cannot be Pareto optimal, क्योंकि कहीं ना कहीं इस लेंस में तुम्हें improvement मिल जाएगा. But if they are tangent, then there is no way to make improvements such that without making one person worse off, right? So if things are intersecting, if ICs are intersecting, improvement is possible, there are Pareto moves possible, and if there is a point that is Pareto optimal, that necessarily means that the ICs are tangents. Okay, so then this, using the second condition, right, what we have is that a necessary, so we have essentially arrived at a necessary condition for Pareto optimality. Okay, so it basically means that at a Pareto optimal allocation, ICs are tangent, and tangent means what? That their slopes are equal. And in this in turn means that the marginal rate of substitution, right, between X and Y for Rahul, so the superscript is for the consumer, the subscript is for the two goods that we have in the economy. The marginal rate of substitution for Rahul is the same as the marginal rate of substitution for Fiza. And this in turn implies that so we know that the marginal rate of substitution is the slope of an indifference curve, and this is also equal to the ratio of the marginal utilities of the two goods. So this essentially means that the marginal utility of X for Rahul upon the marginal utility of Y for Rahul is the same as the ratio of marginal utilities of X and Y for Fiza. And a point that satisfies each of these are one and the same conditions. A point that satisfies this condition, that point will be Pareto optimal. Okay, so if a point is Pareto optimal, it will necessarily, at that point, this will hold true. Okay, all right. Now from here, let us move to what is called, so this is I hope this is clear. This is essentially saying that even though there are a lot of Pareto moves possible from W, right, there are a lot of Pareto moves possible, but actually Pareto optimal points will be a smaller set, and Pareto optimal points will only be the points where the ICs are tangent. And we know that if ICs maintain their shape for an individual and for a given set of goods, ठीक है, तो अगर ये IC है तो कोई दूसरा IC, if this is the IC of Rahul, a second IC cannot cross this given indifference curve, right? The ICs cannot cross. That this violates the transversity axiom, right? So ICs cannot cross. इसका मतलब कि अगर ये ऐसा है तो हमको basically एक ऐसा line मिल सकता है, हाँ? So हमको 2 points यहाँ पे तो मिल गए हैं, ठीक है? We know that if this is, let's draw it here. So we know that if this is your Edgeworth box and this is your initial endowment and ये अगर ICs हैं initially, ठीक है? So if they are intersecting something like this, of ISA, and if they are intersecting at point like this, right? My IC is not very correct. कुछ ऐसे पॉइंट पे अगर वो इंटरसेक्ट कर रहे हैं, ठीक है, और ये वाला कुछ इधर इंटरसेक्ट कर रहा है इस ग्रीन वाले से, है ना? तो बाकी भी कहीं इसी रेंज में ऐसे इंटरसेक्ट कर रहे होंगे, ठीक है? तो ये ऐसा नहीं जाएगा ऊपर से इस वाले में. The thing is that you can find, if you run your ICs like this, so suppose this goes on like this and your green goes on like this over here, so you will get a set of points, right? That will be a continuous line where these ICs are essentially intersecting, something like this. In fact, something like this. Okay. Is wale se, at this point, suppose if this is the IC of Rahul is given by white, then the intersecting IC of Fiza will be given by something like this, and it will be intersecting at this point. Okay. At any other point, their ICs will essentially be crossing. So on all the points on this line, the ICs will be tangent. Something like this. And this line is then what is called the contract curve. So the contract curve is the set of all Pareto optimal allocations. All right. And of course, it is defined for the Edgeworth box. So set of all Pareto optimal allocations in the Edgeworth box. And we know that Pareto optimal allocation essentially means that the ICs are tangent. So the entire line, this pink line, this is called the contract curve. Now, of course, if you start at a point like W over here, right, you will not end up at a point like here. So your final point where you will actually end up depends on your initial allocation. If you start here, you will only be moving 2 points that are within the lens, right? Because if you move here, this will not be a Pareto move. You will make someone worse off, right? So all the moves that will be possible, that all the moves or Pareto moves will be possible, that are possible from here, will be inside this lens only. And within the lens, the only points that are Pareto optimal allocations is this line, है ना? ये line. From this end to this end, right? Including the endpoints, because we have seen that the endpoints are also Pareto improvements. So this section of the contract curve which is the set of all Pareto optimal allocations for a given initial endowment. This is called core. So in the entire Edgeworth box, the set of all Pareto optimal allocations. Abhi dekho, if you have an intersection over here, between the two ICs, you cannot have an intersection over here, because for an intersection over here, you will require the ICs to cross each other. तो ये पॉसिबल नहीं होगा, ठीक है. तो अगर यहाँ पे हो गया तो यहाँ पे नहीं होगा. ये इसी कर्व पे सारे परेटो ऑप्टिमल एलोकेशंस लाई करेंगे, बिकॉज the tangencies will happen along this curve only. But within that, within this set of allocations that are Pareto optimal, the actual allocation, the actual final allocation will only be restricted to this point, to this section. And this is dependent on the initial endowment. And this essentially is called the core. Okay. So the core is the section of the contract curve that will actually take place. And this is decided, or this is determined by where you have started. Okay. So, and where on that core, अब यहाँ पे core पे यहाँ पे होगी, यहाँ पे हो, this will then to some extent depend on the bargaining power of the two individuals. So if the bargaining power of Rahul is very high, then we will be somewhere on this side of the contract curve. If it's very high, if Fiza essentially has no bargaining power, then this is where we will be, where the improvement of Rahul will be maximized. On the other hand, if Fiza has all the bargaining power, then this is where we will be, where Rahul has been left where he was on the same IC, whereas Fiza has extracted the maximum benefit out of the trade that could happen. Okay, and for anything in between, we will lie in between this contract, somewhere in between the core. Okay. Okay. Again, before proceeding, when we are talking about the contract curve, when we are talking about Pareto optimal allocations, we are not making claims about efficiency. We are also not making claims about, we are not making claims about equity, right? So if we are here, or if we are here, we know that here Rahul was had a lot of bargaining power and or extracted all the gains from trade. Here Fiza extracted all the gains from trade. But we will not make comparison between these two points. We will not compare two Pareto optimal points on the basis of equity. This is a statement that we'll refrain from making because we don't know, right? Essentially, of course, this is something, suppose some allocation started here. The initial allocation was here. We know that whatever allocations here are will still be highly unequal. Here Rahul has most of everything. Rahul has a lot of bread, Rahul has a lot of rum, and Fiza has small quantities of both. And when they move here, ultimately, whoever starts big also ends up big, right? So if the initial allocation is very unequal, the final allocation will also be unequal, right? It will not solve the equity problem. What it will solve is that given that allocation, if you take that allocation as given, take that as the starting point, ये भूल जाओ कि वो equal था या unequal था, suppose वो था वहाँ से जहाँ से हमने शुरू किया. उसके बाद ये जो Pareto optimal allocations हैं, which are essentially improvements from here, even though this is unequal, this is still unequal, still both Rahul and Fiza are better off here than they were here. So we will only make statements about the goodness or the desirability of Pareto optimality when we are comparing it with the Pareto not Pareto optimal or Pareto inferior allocations. So all statements about the desirability of these points will be in terms of their desirability over this point. Okay, will be in terms of how these are better than where we started. Of course, where we started itself was unequal, right? Itself was not very desirable. But ये जहाँ से हमने शुरू किया है, उसके बाद जो भी movement हुई है, whichever this Pareto optimal points are allowing us, that is definitely an improvement from this. Because not only the one who had everything, who had like more of everything, not only that person got better off, the person who had less of everything also definitely was better off. Because now they're at a bundle that is giving both of them a higher utility, or at least one of them a higher utility without making anyone else better off. Okay, so statements about Pareto optimality, we will not compare points which are Pareto optimal. We will only make comparisons about the desirability of Pareto optimality. You understand that efficiency is desirable because when we were here, the size of the pie could be made better, but how that increased size is distributed among the agents is something that Pareto optimality does not concern itself with. Okay, but what it concerns itself is that starting where we were, things have been made better. The size of the pie has increased. All right. So now let us come to the discussion on competitive equilibrium. Competitive equilibrium, right? So far what we have assumed is that, Rahul and Fiza, because they are only two people, so what they can do is, and they know कि भाई Rahul के पास कितना bread है, कितना rum है, Fiza के पास कितना bread, कितना rum है. So what they did was they talked among themselves and they decided that okay, let's exchange some of it. You give me some of yours, I'll give some of mine, and then we both will reach a bundle where things are better for both of us, a bundle that gives both of us more utility and at least doesn't make any one of us worse off. But this is fine if you have two people, maybe three people, right? But even with two people, this becomes problematic if the number of goods increases. And even with two goods, this becomes problematic if the number of people increase. So essentially, the barter system, and this is why the barter system slowly gave way to the market mechanism, is because the barter system requires a lot of information. The barter system requires कि तुम्हें ये भी पता हो कि भाई तुम्हारे पास क्या क्या चीजें हैं, किस चीज का क्या बंडल है, तुम्हें ये भी पता हो कि सामने वाले का बंडल एग्जैक्टली क्या है, राइट, हाउ मेनी ऑफ व्हाट थिंग्स दे हैव. Apart from this, the more important information is that you should know how much you value one good in terms of the other good, right? So if there are two goods, you should know how much you value rum in terms of bread, right? So how much is one unit of bread worth in terms of units of rum. But if you have three, right, so then you need to know this this exchange in terms of each of the other two goods. If you have four, if you have five, then you know that the number of values in which, the number of units in which you need to compute the value of a particular good increases, right? So that's why barter becomes more and more inefficient as your economy becomes more and more complex. So हम क्या करेंगे? Now we will try to achieve the same Pareto optimal outcomes, right? But we'll try to do it using a market mechanism, okay? And to see how this will be done, now again it can be a little unrealistic to imagine since we have only two people and of course they can talk, but what we are doing, why we are doing is that so that this can be generalized to a larger economy, a more complex economy. तो हम क्या स्टोरी इमेजिन करेंगे अभी? सो व्हाट वी हैड वाज, हमारा आइलैंड था जहाँ पे वी हैड आवर राहुल एंड फिजा, दीज ओनली टू पीपल वर लिविंग. नाउ थिंक दैट देन एन ऑक्शनियर comes. An auctioneer, you can think of, I mean, probably in today's times, it's better to think of an auctioneer like someone or like an app or like some AI person, right? Some artificial intelligence. The point is that ये auctioneer को of himself or herself, this auctioneer does not have any endowment. So this auctioneer does not have any endowment of either bread or rum, first. Second, ना उसके पास है ना उसे इंटरेस्ट है. So उसको उसका पर्सनल इंटरेस्ट ना ब्रेड में है ना रम में है, ठीक है? उसको खुद के लिए कुछ नहीं चाहिए, उसका काम है to facilitate the trade. And how to do that, I'll just tell you, right? So instead of thinking of someone like an auctioneer, which again has human features, and then you start thinking about why this person will not have any interest in this exchange of things that is happening between Rahul and Fiza, you can think of something that is non-human. You can think of it as like an app that someone has developed. Like suppose they start using an app, or suppose they start using some AI tool or something, right? So the purpose of this AI tool is to facilitate a market mechanism in this small economy. And how that will work is, so this auctioneer or this AI or this app comes, right? And the process how it will work is, in the first step, this AI will announce. So I'll just call it AI. You can call it auctioneer. The reason it's called auctioneering, because this entire process is called Walrasian or competitive equilibrium auctioneering process. Okay? So this AI, or let's just call it A. Okay? So A will announce a set of prices for both rum and bread, right? So we'll call the price of good X as PX and PY. Okay? And what it will tell Rahul and Fiza is that this is the set of prices, and whatever endowment you have, at this price I will buy any quantity of X and Y that you are willing to sell me. ठीक है? तो ये सपोज जैसे MSP अनाउंस करती है सरकार, तो MSP का क्या है कि इस MSP पे हम जितना भी आपका प्रोड्यूस है हम उसे वो प्रोक्योर कर लेंगे, राइट? सो however much you want to sell, we will buy at this price, and after that what we do with it is nothing, that it's not your concern, right? So essentially क्योंकि auctioneer का interest तो bread और rum में है नहीं, तो essentially वो acquire करके, then if it acquires from Rahul, it will give it to Fiza. If it acquires from Fiza, it will give it to Rahul, right? So it will not keep anything for his or her own consumption. So that's why it helps to think of it in terms of something that is non-human. So this tool essentially will announce price PX and PY and say that at this price I will buy whatever quantities of bread and rum that you want to sell me, and then it will ask each of the consumers कि भाई you decide what you want to do at this price. So suppose, just think of it, so if the price of say X is very high, then if you think in money terms, then you will like कि चलो इसका मेरे को बहुत अच्छा दाम मिल जाएगा, right? So you will be willing to sell more of that good. Prices are what? Prices are reflectors, or prices are measure of the value of a particular item in the economy. Value, right? So how the agents value a particular good, prices are metrics of that. तो अगर किसी चीज का प्राइस हाई है, मतलब कि इकोनॉमी में उसका वैल्यू ज्यादा है, so it makes sense to sell more of it and then get a higher price for it and then buy more of other good with that price. Okay? So now what happens is, before we go ahead in discussing the budget constant and everything, you have to note that this is an economy without money. कोई पैसे नहीं है इसमें. So ये जो prices of X and Y है, these are not prices in terms of money, but these are what are called relative prices. So these are relative prices. So it means that the price of bread can be quoted in terms of rum and the price of rum can be quoted in terms of bread. Okay? So if it looks something like this, so suppose PX by PY is 2. So that means that PX is equal to 2 PY, correct? And therefore, if you have 1 unit of good Y, you can exchange it for 2 units of good X, right? So the price of X is twice the price of Y. So if you have the price of X is twice the price of Y, that means X is more valuable than Y. So 1 unit of Y is worth half unit of X. I spoke the other way around. So 1 unit of Y is worth half unit of X, which means that X is more valuable in this economy than Y. All right. So when prices can be quoted in terms of ratio, then what you can do is you can set the value of any one of them, any one of the prices as equal to 1. What it does is that it only changes the scale. ठीक है? अब अगर PY 10 है तो definitely we know that PX will be 20. So if PY is 15, we know that PX will be 30, right? So essentially what matters is that PX is double of PY. It does not matter what PY is. So to make things simple, one thing that is commonly done is to assign one of the prices a value of 1. And whichever, suppose if PY is assigned a value of 1, PY का value तुमने 1 पे fix कर दिया. This is just for simplicity of analysis. So then this Y is called the numeraire good. ठीक है, जिसको हम बेस लेके बाकी सारा काम कर सकते हैं, जिसके टर्म्स में हम कोट कर सकते हैं एवरीथिंग एल्स. ठीक है, नाउ दिस इज द फर्स्ट थिंग. The second thing is that once the prices are announced, Rahul and Fiza cannot affect the prices. So they take the prices as given, right? So first is that these are relative prices. The second thing is that Rahul and Fiza take them as given. Okay. This is basically an assumption of competitive market where they cannot influence the prices. The prices, उनको जब prices बताए गए, they have to make whatever decisions they want at those prices. They know that their actions will not affect the prices. Again, in a small economy, this may be an unrealistic assumption. That's why it helps to think that the prices are imposed by an auctioneer, imposed by an app, and therefore cannot be affected, cannot be changed by either of the two agents. Okay. And the third thing is that this is an economy, as I said, without money. So now we have to think about how to frame the problem of utility maximization for each of the agents. Okay. So for that, what we will do is, so for any utility maximization, for suppose the prices have been announced, we know that utility maximization exercise looks like this. So for individual I, it will be maximize utility I subject to whatever is the allocation of individual I, right? Utility I, which is a function of the allocation, which is a function of the bundle, and subject to the budget constraint. Right? So now we know that utility is fine. Utility is something we know the values of XR, YR, XF and YF. But budget constraint क्या होगा? पैसे तो है नहीं इस economy में, ठीक है? So there is an economy where the only resource is the goods that you have. It's the goods that you started your endowment with, started this transaction with, which is your initial endowment. Your initial endowment is your रिसोर्स, इज योर बजट कॉन्स्ट्रेंट. ठीक है, जैसे हम बोलते हैं कि इनकम है, तो जो इनकम से हमारी इनकम है, दैट इज आवर बजट कॉन्स्ट्रेंट. दैट इज एसेंशियली व्हाट वी आर ट्राइंग टू से हियर. So again, if so, this we will not add things like, so the initial endowment for Rahul is what? It is XR and YR, right? Now if you wanted to add, if you wanted to somehow give a value to this initial endowment, you of course cannot do it like this. ठीक है ना, क्योंकि ये ब्रेड है, ये रम है, इसको ऐड करने का कोई मतलब बनता नहीं है. ठीक है, so what we will do is, just like we do in when we have money in the economy, we want to add the value that economy places on this good and the value that economy places on this good. If it was money, what we do is we multiply the amount that we have of X with the price that the market has placed on X, right? Price is reflecting the value that X, that the value of X in the market, and similarly, so this is XR, okay, plus whatever value the market places on Y. ठीक है, तो ये हमारा राहुल का बजट कॉन्स्टेंट हो जाए. And since, for example, your px was equal to 2 times py, right? So what you will get is, so if you replace px, which is 2 times py, you will get xr naught times 2 py, replacing the value of px in terms of py, plus yr naught py. And suppose this bundle is essentially 5,7, right? So you have 5 units of bread and you have 7 units of rum. So then this becomes 5 times 2 py plus 7 times py. Correct? So this becomes 10 plus 7 py. And what we have done is we have expressed the budget constraint of Rahul in terms of the price of y. And अब अगर तुम y को numeraire good ले लेते हो, if you assign this a value of 1, if you give it a value of 1, the budget constraint of Rahul essentially becomes 17. So this means that this bundle that Rahul had, this bundle is equivalent to 17, and since this is the py, or y is the good in terms of which we are expressing everything, हमने x को भी y के terms में express कर दिया. So this bundle of 5 units of bread and 7 units of rum is equal to 17 units of y, 17 units of rum. ठीक है? तो इसका मतलब ये हुआ कि हमने, if your y had been in terms of say money, then we would put some currency value over here, right? So suppose this bundle is equal to 17 rupees, but अब यहाँ पास rupees तो है नहीं, हमारे पास money है नहीं इस economy में. So then we are expressing everything in terms of one of the goods. So a bundle like 5 goods, 5 units of bread, 7 units of rum is equal to 17 units of rum. It can also be expressed in terms of bread, where you replace py is equal to px by 2, right? So it is equal to 17 units of rum and some other units of bread. Okay? So make sure you understand this, that this is the budget constraint is the value of your initial endowment, and this is not equal to, so the budget constraint is equal to value of initial endowment, and this value is the value that the market places on it, and this is not equal to the utility of the initial endowment. Because this bundle will give some utility to Rahul and some other utility to Fiza, right? Utility is agent specific, but the value that market places on a particular bundle of goods is the same for everyone. ठीक है? तो बजट अब 100 रुपए तुम्हारे लिए और मेरे लिए एक ही होने चाहिए ना. हमारे पास अगर 100 रुपए हैं, so you should also be able to buy the same amount of goods with it as I can. This value that the market places on this bundle should be the same for both, and this value comes from the price. Just that in this economy, it will not be in terms of currency, but it will be in terms of one of the goods that you choose to be the numeraire good. Okay? So now what we have is that for the, suppose for Rahul, so the optimization exercise will look like this. It will look like this. So for say Rahul will be maximizing utility given the bundle that he ends up with, right? Subject to the constraint that the value of the final utility xr times px plus yr times py should be equal to the value that this person started with. Right? So अगर ये 17 था where the market was placing a value of 17 RAM units on this bundle's value should also be the same. So similarly, you will also have an equation for FISA. Correct? So this is your budget constraint, which is essentially saying that the bundle that you end up with should have the same value, same market value as the bundle that you started with. So this is the budget constraint in this economy where money is absent. Okay? So now we know how to solve this. We know that this will be solved where the indifference curve, right, will be tangent to the slope of this, or rather, or another way to express, where the slope of the indifference curve will be the same as the slope of the budget constraint. Right? So you can say that optimal bundle for Rahul such that slope of IC of Rahul is equal to the slope of the budget line, and the slope of the budget line we know is given by the price ratio. Okay, I'm not going into details here. This is something that you may have done multiple number of times. If you have questions, then we can talk about it later. We can talk about that topic later altogether. But essentially where your IC is tangent to the budget line, and this will hold true for both of them, right? So for Rahul, this will be the case, and for FISA, this will be the case. So slope of the indifference curve for FISA will also be Px upon Py. Okay. So one thing that is clear out of this, that if the slope of this IC is equal to this and the slope of this IC is also equal to this, that means that the slope of these two ICs will be the same at the point where they choose their where they choose their optimal bundles, right? So we know that the slope of the two ICs will be the same. So one of the possible ways, one of the possible allocations could be something like this. Again, the Edgeworth box. Suppose this is the initial bundle, okay, and this is your price line, Px by Py. Okay, ये जो भी ratio है, this ratio, of course, the price line is negative of this, है ना? Budget line का slope इसका negative होता है, but we can easily take it to be the absolute value, right? Now we know that the slope of the IC of Rahul has to be the same, something like, suppose this is the point, ये Rahul का final desired allocation है, and the desired allocation of FISA slope has to be the same, is something this, right? So at this price level, suppose the slope of Rahul's IC coincides with the price line at this point, where then Rahul says that, okay, this is my optimal bundle that I desire at this prices, right? And similarly, FISA says that this is this is my desired bundle. We can easily see that this then, whatever is the bundle at AR, BF, AR, BF is an allocation. ठीक है, यहाँ पे कुछ values of X and Y है, यहाँ पे कुछ values of X and Y है. We can easily see that this is not feasible. है ना? ये देखो, यहाँ पे इसका जो है demand for X is this plus this, right? So demand for X in this allocation, we have that demand of X is less than the total supply of X that is available, is less than the total availability of total available units of X. And for Y, this is what, for Y, this is the y that is desired, or this is the y that Pizza wants, and this is the y that Rahul wants. And this plus this is greater than the total available units of y. So demand for y is greater than the total that is available. Okay? So at this price, essentially what is happening, now remember ये price तो artificially बाहर से announce हुआ है ना? This is something that the auctioneer announced. So at this price, what is essentially happening is that there is an excess demand for y and there is an excess supply of x. We know what happens in this case. We know that now the relative price of x needs to come down. The relative price of x needs to come down. So if px by py was 2, right? Now it needs to somehow maybe come down to 1.5. X needs to become less costlier in terms of y. Earlier, if you could get 2 units of y for 1 unit of x, right? Or rather, if you could get, think about it like this, अगर ये तुम्हारा budget वो है, if this is your budget constraint, if this was your px by py, right? So here you had, if you gave up this much x, you could gain this much y, right? Now your x needs to become cheaper in terms of y. That means y needs to become costlier in terms of x. So when you give this much x, the gain in y should be lesser. So if you reduce the slope of the line, if you reduce the slope of this line passing through the same point, okay? So then if this is your new budget constraint, if this is your new budget constraint, then for every decrease in y, the increase in y will only be this much, right? So essentially it means that your budget line, the px by py, needs to become flatter. Now this is what the auctioneer will be thinking कि भाई जो मैंने price assign किया उस price में जो desired bundles हैं, they are non-feasible, right? They are not feasible. You have excess supply and excess demand, so the prices need to be corrected. The price of x needs to come down, the price of y needs to go up, and that means that this line needs to become flatter. Their exchange rate needs to now be more in favor of y. Okay? So when this adjustment happens, again they will choose a bundle, right? This series of adjustments will stop when they finally land up at the same, at one point in the Edgeworth box, and that will be the point that is where this process will finally stop and the market mechanism will have allocated things. So it will look something like this, where this was the initial bundle, right? Earlier, if this was your line, अगर कुछ ऐसा था, ठीक है? So now it will become flatter. It will become something like this, and at this point, your ICs will converge because they will both choose the same point, right? And this will become a feasible allocation. Right? And both of them will, at that price, both of them will have maximized their utility, because we know that this tangency between price line and utility indifference curves comes from utility maximization, right? So at this point, at this final, say P, both of them will have maximized the utility. And we already know, now this is the point that is important, we know that a point where the indifference curves are tangent to each other, right? Earlier they were tangent to the budget line, but they were not tangent to each other, okay? So at the point where the indifference curves are tangent to each other, that point is a Pareto optimal point. So we can easily see from this that P is Pareto optimal, implies P is on the contract curve. इनफैक्ट P will be inside the core only, ठीक है, क्योंकि अगर वैसा नहीं होगा so then we will be making one person worse off, and that will not be the choice, that will not be the optimal choice of that person. So someone is starting at W, right? An optimal choice cannot make the person worse off from you, utility has been maximized, तो इनिशियल बंडल से उसको वर्स ऑफ तो करेगा नहीं, ठीक है. सो दैट एसेंशियली मीन्स कि हमारा जो ओरिजिनल डायग्राम था उसमें जो कोर वाला पोर्शन था, ये जो मार्केट मैकेनिज्म से हमारे पास पॉइंट आया है, दैट विल लाई इन द कोर. ऑफ कोर्स इट विल लाई ऑन द कॉन्ट्रैक्ट कर्व बिकॉज वी वाज ऑलरेडी एस्टैब्लिश्ड कि ये tangent ICs are tangent. ICs are tangent to each other. They are tangent to the budget line, but they're also tangent to each other, which means that this point does lie on the contract curve. But within the contract curve also, it does lie in the core itself. Okay. So what we have is that competitive equilibrium, right? So essentially this point then, the point P, which has been reached by this correction of prices, the announcement of prices, optimal decision making, then correction of prices, and then again optimal decision making. This entire जो ये process है, इसको बोलते हैं Walrasian auctioneering process. Okay, so this entire process is called Walrasian auctioneering process. Okay, this point P, which has been reached after this entire process, this is called a competitive equilibrium. This is called, the end result that we have got is called competitive equilibrium. The price ratio, which we will call Px star by Py star, right? These will be called competitive price ratios. Okay, and finally the allocation which there is, ये जो AR star PF star, the final bundle choices after optimizing their own utilities, the final bundles that are allocated to Rahul and Fiza, these are the competitive equilibrium allocation. ठीक है, तो ये जो competitive equilibrium आया है यहाँ से P से, so this competitive equilibrium we can see that it is a Pareto optimal point. It is a Pareto optimal allocation. ठीक है, and anything else? So it's a Pareto optimal allocation and P belongs to the core. It will lie in the core because, as we have said, P is a point that maximizes utility for both of them, and the utility will not be worse off if Rahul is maximizing his utility starting from an initial bundle here. The utility will not be worse off than what he started here. ठीक है, तो वो उस लेंस के अंदर ही होगा, कोर में ही होगा और वो कॉन्ट्रैक्ट कर्व के ऊपर ही होगा. So this is about competitive equilibrium. What we have essentially seen is that there are two ways to get to Pareto optimal allocations. There are, the one way was the barter process, right? And the other way was through this market mechanism. Now, when we think of market mechanism, this auctioneer or this AI or something, this is something that is fine. If you have multiple goods and multiple people, ultimately this is a system that works itself. So you suppose you start at a given price ratio between two goods, and then depending upon what is the value or what is the utilities, there is the price ratio gives the value that the market places on those two goods, right? But the value of the good is also determined by the utility that people derive out of those goods, right? So when these two forces interact, the final price ratio, एक को वो करोगे जैसे कि तुमने the market is placing a higher value on a good that the agents essentially don't value, right? So then the price needs to adjust in the sense that the price of that good needs to go down, and then this correction of prices, continued correction of prices, this is the market mechanism. And this market mechanism will again end up in a result that is Pareto optimal. Okay? So this brings us to the final section in this lecture, which are the welfare theorems. Okay? So welfare theorems क्या है? There are two welfare theorems. There's the first fundamental theorem, the first and the second fundamental theorem. The essential idea of welfare theorem is so these theorems talk about the relationship between efficiency and market mechanism. All right. When we talk of market mechanism, we are essentially talking about the prices, how the value of things in the economy is determined by prices. So a relationship, what is the relationship between efficiency? In this case, we will use the concept of Pareto optimality. So what is the relationship between Pareto optimality and the market mechanism and the allocation of goods using the market mechanism, which is correction or movement in prices, right? So for this, before I state the theorems, we need to specify 3 assumptions that are required for this theorem, right? So now these assumptions are very basic and more or less they make sense, right? You can think that they are not very demanding, but when we go to the real world, they can actually be very demanding. But for now, let's just state them. So first is that there exists a market and market prices for all goods in the economy. So in this case, we have bread and rum. These are the two goods. So the assumption essentially says that there's a market for bread as well as there is a market for rum, and the prices of both these commodities have been determined, have been quoted. Okay, तो ऐसा नहीं है कि एक किसी commodity का missing market है. A lot of times that is something that is true in the real economy, but for now we will be abstracting away from this. There are missing markets for a lot of things in a real economy, and there could be a lot of reasons for it. There could be lack of information. There could be lack of a proper trading facility, lack of tangibility in the product. Due to various reasons, market may be missing for a lot of items. But जो economy हम यहाँ पे consider कर रहे हैं, even if you have more than 2 goods, we are assuming that market exists and the market prices are defined and they exist. ठीक है? The second assumption is that all agents are price takers. So in this case, we are saying that neither Rahul nor Fiza can affect the prices. All right. And the third assumption says that each person's utility, so UI depends only on I's own bundle. ठीक है, सो मेरी यूटिलिटी सिर्फ मेरे बंडल पे डिपेंड करती है, तुम्हारी यूटिलिटी तुम्हारे बंडल पे डिपेंड करती है. ऐसा नहीं है दैट there is no jealousy, there is no altruism. So it's not like you get some sort of happiness or some sort of jealousy when you see my bundle. Your bundle is your bundle, my bundle is my bundle. Okay? So under these 3 assumptions, then let me state the first welfare theorem. So first fundamental theorem of welfare economics, or first welfare theorem. Which says that under assumptions 1, 2, and 3, right? So when I say under assumptions, it basically means that the kind of statement that I'm making is if and then. So if A, then B. If 1, 2, and 3 hold, then the statement I'm going to make holds. Okay, so if that is the case, then if under assumption A, 1, 2, and 3, any competitive equilibrium is Pareto optimal. Okay, the exact proof of this, we know, we have seen it in the Edgeworth box, and our intuition is clear why this will be the case, right? This will be the case because a competitive equilibrium is where the ICs will be tangent. That means it will lie on the contract curve, and if it lies on the contract curve, that means that it is Pareto optimal. And secondly, it will also lie within the core. That is because these are utility maximization choices of both Rahul and Fiza, and that will not put them on worse utility than where they started from. Okay, so our intuition about it is clear. The proof is something that is beyond the scope of this course, so we will not get into it. But we must understand how important, how powerful this result is, right? So what we are saying is that so if markets exist for whatever goods we are considering, if market prices exist, if your utility is your utility and my utility is my utility, and what was the second assumption, which was this competitive market assumption that, you know, agents cannot influence prices, then we are saying that whatever allocation the market mechanism does, the competitive allocation, that will be Pareto optimal. And why is this powerful? Because you see, हमारा जो भी Edgeworth box था, ठीक है? Any Edgeworth box, this is where we had that core wala diagram. Now let me just go there. So this is the diagram. So suppose for this allocation, right? For this allocation, this is the core. पहली बात तो, the probability of landing upon a distribution that is on the contract curve is theoretically zero, because the probability is given by what? Probability is given by the under the probability of a particular subsection in this area is given by the area of that subsection, right? And the probability of a line is zero. So theoretically, the probability of landing anywhere on the contract curve is zero. That means that if suppose there was any mechanism, you were trying to make allocations using any mechanism, ठीक है? अभी तो हमारे पास दो लोग हैं तो हमने बार्टर कंसीडर कर लिया, बट अगर हमारे पास हजारों करोड़ों लोग होंगे और हमारे पास हजारों प्रोडक्ट्स होंगे, in that case, if you make any allocation, there is a negligible or there is a zero chance that that will lie on the contract curve. That means that it will be a Pareto optimal allocation. ठीक है? उसके chances almost negligible है, ठीक है? But the big thing is that if you use the market mechanism, if you let prices decide the value, the prices and the utility that the consumers have, right? These price taker agents, if you let prices do their thing, you will not only land on the contract curve, you will land on the core. You will make an allocation that will be Pareto optimal. It will make everyone better off without making anyone worse off. At least no one will be made worse off, right? So this is a very powerful result, the first welfare theorem, because the chances that you get such a desirable allocation using a mechanism, using the market mechanism is pretty powerful. Okay, so this is the first welfare theorem, which is saying that if you have a certain set of basic assumptions satisfied, in that case, the market mechanisms produces a Pareto optimal allocation. Okay, अब, even though it is very powerful, the basic problem with this, right? So we understand what is the appeal of this theorem. This theorem is saying कि भाई market को अगर अपने हिसाब से काम करने दोगे, So the allocation that the market will make will be Pareto optimal, right? So it will not land up at a point from where further improvements can be made without making anyone else but worse off, right? So it will end up at a point where the size of the pie is the largest, given the initial, right? We know that as good as that may be, Pareto optimality does not concern itself with fairness of distribution. You know? So the biggest drawback or the biggest problem with the first welfare theorem is that the competitive equilibrium is highly dependent on the starting point. And this is one of the major criticism of capitalism per se. So हम capitalism बोलते हैं कि merit decides everything. So if whatever good that you produce or whatever endowment of things that you have, if the market values that product, right, then you will get the correct price, and then everyone will be better off. You will arrive at an allocation that is Pareto optimal in the way we have defined it. The problem is that it ignores the fact that the endowment itself is often extremely unequal, right? So this is the same thing that we talked about earlier, that given the endowment, given the initial endowment, suppose this is the initial endowment, right? This initial endowment has most of the things is with Rahul, and Fiza has only a small proportion of these. Okay? Given this initial endowment, इसका कुछ ऐसा indifference curve होगा, and on the contract curve, suppose this is somewhere you lie. This is where you end up, right? Let us call this the laissez-faire outcome. Laissez-faire का मतलब होता है फ्रेंच में let be. So it essentially means the unleashed free market. एकदम ही free market कि भाई तुम बिल्कुल भी छेड़खानी मत करो. Let's just take whatever endowments people have as given. Let's start with the society wherever it is, where Rahul has more of everything and Fiza has less of everything, right? Let's keep that as given, and then let the market work. So this will also lead to a Pareto optimal allocation. This will Pareto dominate this. Both of them will be better off, but this is not good enough. Right? This is not good enough. We don't want, we somehow want to correct this inequality in the market also. Okay? Inequality in the society also. So then, and so what we will call this? We'll call this where the markets are unleashed, the free markets are doing everything. There is no intervention from mostly it's from the government, right? So there is no intervention जहाँ पे markets को खुली छूट है to decide who gets how much, right? And that is heavily dependent on your initial allocation. That we are calling the laissez-faire outcome. Okay? But we know that an allocation somewhere here, right, will be more desirable. है ना? हमको ये पता है कि कहीं इधर पे ज़्यादा मतलब it will be more fair, it will be fairer, it will be more equitable. ठीक है? So suppose let us define this point. This is the point where, let's call it target. And this is the point where we want to reach. So target is the desired allocation. Okay. Notice that target is still on the contract curve. So we are not in our quest for equity, we are not abandoning efficiency. We still want it to be on the contract curve where where the size of the pie is maximized, where there are no Pareto moves possible. तो हमको फिर भी Pareto इस contract curve पे ही एक point चाहिए, लेकिन ऐसा point चाहिए जो कि इस free market वाले outcome से ज़्यादा equitable. ठीक है? So this is where, so can we get there? Can we get there? And how do we get there? So this is where the second welfare theorem comes in, and the second welfare theorem says that we can get here and we can still use the market mechanism to get here. Okay, so let me state the second welfare theorem, and then I will explain how that is. For the second welfare theorem, so we need an assumption, additional assumption, a fourth assumption, and this is again something that is generally it is true. We require that the ICs of the agents are convex. Okay. So this is a very standard assumption, but it was not required per se in the first welfare theorem. For the second welfare theorem, this is something that we will require, and the second welfare theorem then says that, so let me write the second welfare theorem. Where it says that under assumptions 1, 2, 3, 4, 1, 2, 3, 4, right? Under assumptions 1, 2, 3, 4, we have that any Pareto optimal allocation, can be achieved using the market mechanism and a set of zero sum lump sum taxes. Okay. So what this is saying is that, this will become clear. Let me just explain it using this diagram. So what this is saying is that, suppose this is where we are starting, and using the market mechanism, if nothing is controlled, this is where we'll be, but we want to be here. हमको ये वाला point चाहिए. This is more equitable. What this is saying is that the second welfare theorem, that you can get here, and you can get here using the market mechanism itself. All you need to do is change the initial endowment. Change the initial endowment. If the initial endowment is changed from here to somewhere here, ठीक है, मान लो कि ये I था and this is the final endowment. If you change it to the point F and then you let the markets work, so you will get, again this will be your ICs, okay? You will get to this point. The markets will work and you will get to this point. Okay, so how does that work? Let's see. What we are saying is that, again, we had the auctioneer was deciding the prices. Now let's say that there's a government, and again this government is something that is not interested in any of the products. It is not personally an owner of any of the goods, any bread, any rum, and also it doesn't want any bread, any rum. ठीक है, तो इसका भी काम सिर्फ facilitate करना है ना? So you can again think of it as the auctioneer himself or government or something. You can think that the two are the same and one and the same person or one and the same entity. ठीक है, so what this will do, this auctioneer announces that there are a set of taxes / transfers. Okay, so what we will do is that suppose this is what you have for Rahul. You have XR0, YR0, right? And for Fiza you have this. Now this government says that both of you will get a tax slash transfer. So it will be a tax if your TR is positive, sorry, if your TR is negative, and it will be a transfer if your TR is positive. So you can think of it as a lump sum amount. It's lump sum because it is not dependent on any of the final quantities that you decide. It does not increase, it's not a function of anything, right? It's an independent amount. It's lump sum. 100 रुपए हैं तो दोनों के लिए 100 रुपए हैं. There are two conditions on this. First, that it is lump sum. It is not a function of any of XF or XR or YF or YR. Okay? So TR and TF are lump sum. And secondly, TF plus TR is equal to 0. This is called zero sum. So you can think that ये जो भी exercise हो रहा है, this is essentially not creating any additional value in the economy. कोई extra unit of bread या extra unit of rum तो आया नहीं है, ठीक है? So the size of the resources in the economy is still the same. This then is essentially just a transfer. So if, for example, TF is positive, then that means that TR is negative and TR is exactly equal to minus TF, right? So if TF is positive, that means that whatever is the initial budget or initial endowment of visa, which is what? XF naught times PX plus YF naught times PY, there will be some additional amount that will be given to her. Okay, and where will this amount come from? This will be deducted from Rahul. Okay, we will put it as plus on both sides. It can be negative and it can be positive. So then what is happening is, if suppose Rahul का initial bundle हमारे पास क्या था, 17 था, 17 units of rum. Now, since this will also be specified in terms of the goods only, so you can think that TR is minus 3. So then, if it was initially 17 units of rum and TR is minus 3, so then this person, Rahul, is now left up with 14 units of rum. And whatever the extra was, that minus 3 that was deducted from Rahul, is all of it is transferred to Fiza. And now Fiza, whatever she had initially, अगर इसके पास initially मान लो कि 3 था, because it was a very unequal distribution. So initially if it was 3, so now she will have 3 plus 3. So she will have more of it. So now initially if the income distribution or if the budget distribution was 17,3, now it will be 14,6. More equitable. Of course, this can be anything else also. इसको अगर 6 मान लेते हैं, तो then we will have 11,9. Even more equitable. All right. So what this transfer will do is, it will put people from this initial point to this initial point. Okay. And then the second thing that we need to do is decide the prices. ठीक है? अब ये prices ऐसे भी जा सकते हैं, ऐसे भी जा सकते हैं, ऐसे भी जा सकते हैं. ठीक है? हमको वो price चाहिए जो कि ये contract curve पे lie करे. Right? And this is also something that can be that can be easily done. How is that? We know that target lies on the contract curve, right? So if it lies on the contract curve, it quickly means that it's a tangent point of the ICs, right? That means that the slope of IC1 will be equal to the slope of the IC2, and this should be equal to PX star comma PY star. So इनमें से जिसका भी slope उठा लो, whatever slope you have, this slope will give you the relative prices of X and Y. So what the government now does is, first of all, the government announces the initial bundle, or rather the government announces the taxes / transfers. It tells you कि भाई, and of course, since agents are price takers, agents do not have a say in this, right? So then the government tells Rahul कि भाई तुम्हें 3 और 6 का tax लगेगा, and it tells Fiza that you will get an extra 6 units of rum or whatever, a good that is valued as 6 units of rum, right? So what this will do is, it will move the allocation from here to here. And secondly, it will announce the set of prices. The set of prices which will be equal to this, Px star by Py star, which is exactly equal to the slope of these two, क्योंकि ये वाला point contract करते हैं, ये tangent होना ही होना. So once you do that, you put people from here to here and you announce a price that will make this the only end result. This is the second fundamental theorem of welfare economics. You can decide a final outcome. You want things to be more equitable. For that, you can still rely on market mechanism. What is the alternative to this? See, why is the second result powerful? The alternative to this is that you bring in a social planner, right? And then the social planner needs so much information. The social planner needs information, of course, of everyone's bundles. The social planner needs, and this is something that the market will also need, or not exactly need, but some idea of this will be required. But the social planner will also need to know the utilities of everyone else, right? And for that, the social planner will require information that is extremely obtrusive. The market, on the other hand, does not require all that information, right? You can change the initial bundles and the market price. Remember, ये जो हम बोल रहे हैं यहाँ पे that this price will be announced. This is how the market mechanism works. The market does not require to know this. Remember the process. The process is that the auctioneer announces, individuals decide कि क्या करना है उस पे. अगर चीजें fit नहीं हो रही हैं, अगर allocation feasible नहीं हो रहा है, then the market corrects. Here also the same thing will happen. The market will correct, keep on correcting itself, and finally this Px star by Py star will be reached. You don't need information about this to reach this. This is what the market will do. All you need information is getting from here to here, and then you can let the market function. All right. So yeah, so that ends our discussion of welfare or general equilibrium in an exchange economy, right? Even in an exchange economy, this analysis can become complex, as you've seen. I mean, there are a lot of parts to examine. There are parts that are from the market side, there are parts that are from the consumer side. That's why we started simple. In the next lecture, we will also add the production angle to it. Okay, so that is the Robinson-Crusoe economy. So that I'll just give you a preview. यहाँ पे हमारे पास क्या था कि हमारा जो island है उसमें 2 लोग हैं, and we assume that the production has already taken place. The only thing remaining to be determined is the distribution, the allocation, right? There we'll go back a little, थोड़ा सा वक्त में पीछे जाएंगे, where then this Robinson-Crusoe person जो हमारे island पे अकेला बच गया था, जब ये उस आइलैंड पे अकेला था, ठीक है. सो टिल दैट टाइम हमारी फिजा हैड नॉट कम टू द आइलैंड. Rahul was alone on the island, and Rahul was not only consuming things, but Rahul also needed to produce things. So now we'll look at both the production as well as consumption, or the distribution angle of it, and then we will do general equilibrium in this expanded economy. Okay, so this is what we'll do right now. I'll end this over here. The essential conclusion from this is that under the set of assumptions that we have, market mechanism can be trusted to yield Pareto optimal outcomes. Not only Pareto optimal outcomes that are dependent heavily on the initial endowment, but also Pareto optimal outcomes that are artificially determined to make things more equitable. Still, the market mechanism can achieve that, will achieve that. All is required is a set of zero-sum lump sum taxes. Right? So I'll end here. Thank you so much, and I will see you in the next video. Thank you.